In this video, I want to talk about platform scales and how they work. Here I have 3 different ones. I'm not going to say they were restored because some of the parts were missing. And the part that I replaced it with might not be exactly like the original. So these have been cleaned up and repaired. I'm not sure who made these because they didn't cast their name into any of the castings. They probably had a decal on them somewhere, and that decal was long gone by the time I got them. These all have brass beams and brass sliding weights. This one is marked US Standard, and I think that refers to the US Standard weights and measurements. These are all going to be in pounds. This one has a round sliding brass weight. The second one is also marked US Standard, and it has a square sliding weight. The one on the right doesn't have any markings on the beam. The sliding weight on this one is round, and it has a thumb screw on the bottom so you can lock it in place. All these weight hangers are slightly different, but they all serve the same purpose. In addition to hanging weights on them, they have a hidden compartment underneath, so you can add or take away weight as part of the calibration process. On this type of scale, the weights that you use are stored on this rack on the front. Each one of the weights are marked with a couple numbers. This one says 200 because if it's hanging on the beam and the scale beam is floating in the middle of its travel, that means you have 200 pounds on the platform. It also says 2 pounds on it because that's how much this weight actually weighs. Now if you got this one hanging on the beam, it weighs 1 pound, and it would balance out if there was 100 pounds on the platform. The smaller one weighs a half a pound, and if the beam balances with this one on the hanger, then you have 50 pounds on the platform. This beam has markings on it from 0 to 50, and if the sliding weight is on the 50, then the beam would be balancing if there's 50 pounds on the platform. So the sliding weight being on the 50 mark with no weights on the hanger represents 50 pounds. Also, if the sliding weight was on 0 and you had the smallest weight on the hanger, that would represent 50 pounds. Now if I had the 50 weight on the hanger and the sliding weight was at 10 and the beam was balancing, that means I would have 60 pounds on the platform because that's 50 plus 10. So by using a combination of these weights and the position of the sliding weight, you can measure things up to 500 or 750 pounds depending on the scale. One more thing I want to mention while I'm showing the top of the scales is the beam lockdown. I'm not sure if this was meant to be used while you're moving the scale or while you're putting something on the platform. They all have them, and they're a little bit different style. The first two just seem to trap the beam to restrict the movement. This third one actually clamps the beam down so it can't move. Okay then, let's weigh something. This is a weight standard. You need to have a way to see if your scale's operating properly. This one is a 50-pounder. There's that phrase US standard again. And then it says 50 towards the bottom. This particular one's made by Howe, Howe. They were a pretty common scale maker at the time. So this piece should weigh 50 pounds. If I put the sliding weight on the 50 mark, the beam should balance right in the middle of that window. If I move it 2 lines over, that would be a ½ a pound difference. And you can see the beam is up a little bit, so it's not exactly on center. If I move it to the 49 line, the beam gets towards the top of that window. So on this type of scale, to be accurate, you really got to look at whether the beam is exactly in the middle of that window or not. If I put the sliding weight at 0 and I add this small weight on the hanger, that should also balance out, because the small ½ pound weight represents 50 pounds. This weight says RS Company on it. That would be the Richardson Scale Company. It's a 30-pound weight, so I'll put that on top of the 50-pound weight. And if I slide the movable weight to the 30 mark, the beam should balance. So the total there is 80 pounds. Because there's 50 pounds worth of weight on the hanger and the sliding weight's on the 30. So 50 plus 30 is 80 pounds. Now I'm going to go into a little more detail about how they work. All these parts have to balance easily without having a lot of resistance in the mechanism. If you look at this pin right here, it's not just a round pin, but it comes to a point on the bottom. So the beam is resting on that narrow point, and that allows it to move easily. If you look inside the box here, there's a linkage connected to the beam that goes down to the platform. That linkage is resting on a pin, and this pin has the narrow edge facing upward, once again allowing the mechanism to move with little resistance. So let's lift the platform on this one and see how it works. A lot of them will have a locking pin that prevents you from lifting this off. I've already got the pin removed on this one, so I need to lift the outside edge first and slide it towards me. On this end of the platform, there's usually a pin that hooks underneath the frame, and that prevents the other end from being lifted straight up. The platform is supported in 4 places. The back 2 legs on this one are flat, and the front 2 legs have this V shape. So the V-shaped legs keep it centered on the knife edge. There's a little boss here with a hole in it, and that's where the locking pin goes, and it hooks under this lip right here that's in the casting. So when that pin's in place, you can't get the platform off. All this stuff in here should be floating freely, so I can move it around like that. Here you can see the pins where the platform rests, and they're also teardrop shaped with that narrow edge facing upward. There's 4 of those, so each leg of the platform is supported. If you look at the smaller triangle shaped casting here, it's supported in 2 places, and that supports 2 legs of the platform. It's hanging on links, and the pin that hangs in the bottom of that link has that teardrop shaped pin again. So the narrow edge of that pin is riding on the bottom of this link. So all the weight that you put on the platform is hanging on these links. This link over here was missing, so I had to make one. It looks a little different, but serves the same purpose. When there's weight on the platform, 2 of the legs are pushing down on the small triangle, and the other 2 legs are pushing down on the larger triangle with this arm on it. The 2 triangle pieces are connected together with this link in the middle. So all the weight put on the platform is pushing down on this arm that connects to the link going through the box, and that connects to the beam on top. The more weight on the platform, the harder it pulls down on the beam. When you put the platform on, it'll be located lengthwise because the legs with the V shape in them will center themselves on those pins. To position it side to side, I move it to see how far it'll go in each direction, and then I move it to the middle. So the platform should be floating and not hitting against the edge of the frame. Here's the pin I talked about that holds the platform in position, and I need to put it in from underneath. Now the platform can't be lifted off, but when it's sitting in position, it can float without touching anything. Most of these old scales are on wheels because they were meant to be portable. And back when these were made, floors were not all that level. So when you move them to a different place, they might not be level again. So there's a movable counterbalance weight in here. All these old scales will have them because balancing is a critical part of the operation. On the first one, you adjust it by turning the screw, and the counterbalance weight that don't rotate moves back and forth on that screw. If I move this one a ways, you can see the beam don't balance anymore. So you have to adjust the position of the weight to get the arm to balance in the middle of that window. This one here is a little bit different. On it, the screw stays in one place, and you turn the weight to move it back and forth. The principle's the same, just a little bit different design. This third one is like the second one, where you just rotate the weight. This is a picture of a simple balance beam scale. This is the balance point in the middle. The arm on each side is the same length, so it's a 1-to-1 ratio. So if I had 1 pound on this side and 1 pound on that side, it should balance out. If I move the balance point over to the side a little bit, so the ratio of this arm compared to this arm is 1 to 2, then it would balance out if I had 2 pounds over here and 1 pound here. And you can go as far out as you want. In this case, the arm on the right side is 10 times as long as the arm on the left side. So I could have 10 times as much weight over here as I have over here, and it would balance out. This drawing shows how you can use leverage to reduce weight. This represents a scale, this represents the weight, and this is an arm on a pivot point here. This too represents the length of the arm from the pivot point to the scale, and the 1 represents the length of the arm from the pivot point to the weight. Now that means I can put a 2 pound weight here, but the weight on the scale would only be 1 pound. Now you can take that theory as far as you want. If the distance from the pivot point to the scale is 10 times the distance from the pivot point to the weight, then the weight on this arm here would be 1/10 of the weight here. Now the platform scale uses both of those theories. This arm here represents the smaller triangle in the bottom of the scale, and this long arm here represents the larger triangle with the arm that goes out the end so it can pull down on the balance beam. This represents that link in the middle that connects them. So all of the weight that you put on the platform is going to be pulling down on this arm at the end. So I'm not going to show the calculation of the math and how this works out. But what happens is the mechanical ratio of those levers is 1 to 100. So if I have 100 pounds on the platform, it would balance if I had just 1 pound on the weight hanger. So when they make a scale with castings and assemble it, this ratio might not work out exactly to 1 to 100. So to provide a little bit of adjustment there, this large triangle shaped casting with the arm on the end actually has an adjustable section in it right here, so that they can change the length of this arm to get the ratio to come out exactly 1 to 100. There's going to be a bunch of different ways to make these parts adjustable. If we look at one here, this one has a couple of nuts on a threaded rod. And by changing the position of the nuts, you can move this part back and forth. This here is the bottom of the hook that goes up to the top beam. So when you change the position of the nuts, that changes the effective length of this long arm. This one has a different design. Probably easier to make, but a little more difficult to adjust. You would loosen this nut here and slide the smaller piece back and forth in the slot. This is the rod with the hook on it that goes to the upper beam. This scale, the one with the blue paint on it, I believe would have been a more inexpensive model, because the long arm on it does not have an adjustment. So to set this scale up accurately, the procedure is just a little bit different. Well, that's as far as I'm going in this video. I might make another video about a few other types of scales that I have. And I'm considering making a video about how to set up and calibrate this type of scale. If you'd like to see that, let me know in the comments. A few years ago, I made a platform to go on a scale like this, so I could weigh my wheel horse tractors. If you're interested in seeing that, go back and watch one of my old videos called "What's That Old Wheel Horse Weigh?" I'll put a link in the description. So the total weight is 200 plus 50 plus 33. So that's 283 pounds. Alright, that's it.